Inside the machine, separation, and the dirty moat. To really see the grip, step into the hall where the air tastes faintly of acid and metal. Solvent extraction isn't a lab trick, it's an industrial orchestra. Picture parallel trains of mixer-settlers, shallow boxes in long, repeating rows, where two immiscible liquids pass each other in counter-current flow, trading ions like dealers sliding chips across a table. Pumps set the rhythm. Agitators cut tiny droplets to maximize surface area. The choreography decides which element steps left and which slips right. Stakes first because they dictate everything. If the cut isn't clean, purity collapses downstream. Impurities at parts per million change magnet coercivity at 180 degrees C and crash yields on sintering days. Miss a praseodymium-neodymium split, and your alloy's microstructure won't form the desired grains. Your motor runs hot, your spec fails, your line stops. Every valve turn has a cost measured in hours of lost production and months of reputational debt. Operators feel that pressure at eye level. A column off by a pH decimal today becomes a failed acceptance test 3 suppliers away next quarter. Action looks like chemistry under discipline. The feed, cracked and leached ore turned into a pregnant liquor, enters the first stage. An organophosphorus extractant in kerosene meets an aqueous nitrate or chloride phase. At a certain pH, one lanthanide prefers the organic, its neighbor prefers the water. Adjust acidity by tenths and the preference flips. Run 80, 120, sometimes 180 stages to sharpen the separation, recycling raffinate and loaded organic while washing and scrubbing to strip co-extractants. Every 30 minutes, a tech pulls samples, titrates acidity, and charts a McCabe-Thiele diagram that only makes sense if you've been here long enough to see how theory bends under real feed. Meanwhile, something else is happening in the pipes. Trace contaminants, iron, calcium, silica phosphate, ride along and foul extractants. The fix isn't just swapping solvent, it's preconditioning the feed, adding complexants at just the right ratio, watching temperature creep, because viscosity nudges droplet size and residence time. 1 degree shifts phase disengagement, and a single bad disengagement foams a stage, knocks carryover into the next bank, and cascades into hours of cleaning. People talk about 100+ stages as if they're identical photocopies. They aren't. Early banks handle bulk moves, later ones shave fractions. Each bank has a personality shaped by weld quality, pump wear, and the crew that babysits it. Scale multiplies complexity. A pilot plant forgives slop. A commercial line magnifies it. Flow rates in cubic meters per hour demand control loops that don't drift. The control system paces pumps, dozers, and scrapers, but humans anchor the edge cases. A veteran can hear a stage sing wrong, too much cavitation, not enough shear. He'll tap a gauge, tweak an air bleed, and stop a runaway before the chart screams. That tacit skill is the moat you can't order from a catalog. Then there's the waste math, the part polite brochures skip. Every purification step generates raffinate streams loaded with salts and acids. Neutralizing them throws tons of gypsum-like solids. If the ore carried thorium or uranium traces, those solids read mildly radioactive. Ponds need engineered liners, capture wells, and monitoring. Water demand is relentless. Washing organics, scrubbing crud, rinsing equipment. Recycling loops cut draw, but every loop adds its own failure modes. Price the true cost of effluent to Western standards, and the unit economics flip. Ignore it, and your operating margin looks heroic, until inspection day. China moved along that continuum over time, tightening, consolidating, and still keeping enough flexibility to stay price leader. That balance is the dirty moat, the willingness and capacity to manage or absorb waste at scale. Tacit knowledge deserves its own ledger. Operators learn that iron adsorption clays from southern hills feed a liquor that needs gentler gradients to avoid gelation. Bastnasite-derived feeds like more aggressive acidities but punish sloppy temperature control. Teams keep failure libraries, photos of phase inversion, logs of crud bursts, notes on when to swap a degraded extractant because its loading curve flattened. They run solvent health checks like a doctor reads blood work. That playbook is IP a lawyer files. It's muscle memory and a shop culture that treats small anomalies as future crises. Reliability is the product. Downstream magnet makers buy on-spec, on-time flows, not potential. They need oxide at narrow particle distributions or metal at tight interstitial impurity levels, oxygen, carbon, nitrogen kept in single-digit ppm. That requires polishing steps, precipitation controls that set grain size, calcination schedules tuned to phase transformations, metal smelting in vacuums that don't burp. Miss oxygen by a whisper and the magnet's grain boundaries won't take diffusion doping, killing high-temperature performance. That's why contracts tilt to incumbents. They've proven they can make boredom, same number, every week, through monsoon and cold snap. Here's where geography traps ambition. You can open a new mine in Australia or the US, but your concentrate still stares at a midstream gate. Even when you build a separation plant elsewhere, you start with a crew that hasn't stood midnight watch on a crud event. First-year yields wobble, customers hesitate, banks demand take or pay you can't secure without a reliability record you don't yet have. Therefore, material loops back to the same addresses. Therefore, the moat defends itself. In the end, the machine's secret isn't chemistry alone. It's choreography plus consequence. Keep pH where it belongs, heat steady, solvents clean and waste contained, and you print trust. Slip and the pond grows, the spec slips, and the phone rings from a factory you'll never visit, asking why their line is quiet. The geography trap, mining vs. refining. While new holes got drilled in deserts and red dirt hills, concentrates kept boarding ships for the same destinations. Mountain Pass in California is the cleanest example. The mine restarted, or got cracked and leached into a rare earth carbonate or oxide stream, and then, here's the twist, it often needed to leave the country to become metal and magnet. The geology was American, the gate that mattered sat across the Pacific. Australia's leaners fought to break that loop. They dug at Mount Weld, shipped to a separation plant in Kuantan, Malaysia, and built toward metals and magnets with partners. It worked, partly. Community pushback forced tighter environmental controls and slower ramps. When customers needed guaranteed on-spec NdPr oxide every week, the safest path was still a purchase order to long-running Chinese plants. Mines can sprint, separation walks. Buyers don't wait for walking. Stakes for real people live in the calendar. A mining CEO can celebrate first ore, first concentrate, first cash. An OEM planner needs first magnet on time forever. Without a proven separating counterparty, a mine sells at a discount to incumbents who assume the yield risk and capture the reliability premium. Intermediate choke means the value stacks midstream. Upstream optimism meets midstream pricing power, and midstream wins. Action shows up in contracts. Concentrates require offtakers with a track record, solvent extraction banks that have run on this exact feed, with a data pack proving how cerium will be bled, how lanthanum will be routed, how the PRND cut will hold across seasonal temperature swings. That's why ore from diverse geologies, bastnasite, monazite, iron adsorption clays, keeps looping back to processors that can tune the dance fast. Every new separation plant must survive its messy first year, with customers who have zero tolerance for mess. Logistics math sharpens the trap. A bulk shipment from Fremantle to Tianjin adds weeks and thousands of miles, but costs less than a single day of a car plant sitting idle. Schedule risk beats freight cost every time. Incumbents leverage this with contractual lock-in, take-or-pay agreements, penalties for off-spec feed, quality clauses that define on-time more strictly than airport timetables. A junior miner signs because they must. The incumbent processor smiles because they can. Meanwhile, something else is happening in spreadsheets you'll never see. Processors offer tolling deals. Send us your concentrate, we'll return separated oxides minus a fee and a yield share. On paper, it de-risks capital for the miner. In practice, it cements reliance on the processor's secret sauce. If the miner ever tries to switch, they face a requalification cycle that spooks their customers. The ore body becomes hostage to a flow sheet written in someone else's building. Quiet leverage shows up at alloy and magnet houses too. Even if a mine finds a non-Chinese separator, the next step, turning oxide into metal, metal into strip cast alloy, alloy into sintered magnets with specific grain boundary diffusion, often sits in the same coastal zones that learn to treat purity as routine. A European or Japanese magnet maker can and does produce world-class parts, but scale is the sword. When gigawatt-hours of motors need magnets now, the plants that can pull 24/7 at volume write the price and the queue. The trap isn't just technical, it's legal and cultural. Feed qualification can take 6 to 18 months of test runs, audits, and pilot lots. Contracts carry most favored clauses and exclusivity windows. Switching midstream partners isn't like changing a shipping lane. It's like changing a surgeon mid-operation. Everyone in the room prefers the hands they know. A micro story from Western Australia. A junior celebrates a maiden shipment of concentrate. The next week, they send a team to a Chinese separation plant to observe trial runs. The plant manager greets them with a ledger of similar feeds and a schedule slot next Tuesday. Samples flow, pH ladders adjust on the fly. 3 months later, the miner has saleable NdPr oxide. The alternative, a greenfield separator back home, still waits on permits, financing, and a team that's never ridden out a crud bloom at 3 a.m. Unknown to faraway boardrooms, midstream processors curate feed portfolios like asset managers. They blend ores to smooth impurity spikes, hedge reagent supply, and maintain solvent health. If a feed threatens crud rates, it gets throttled or priced harder. If a mine's logistics slip, their slot slides down the queue. Geography doubles as governance. Proximity to reagents, spare parts, skilled repair crews, and port access compounds advantage. Impact ripples back to the mine plan. When tolling or offtake terms cut margins thin, miners chase volume to make up revenue, pushing benches faster and raising strip ratios sooner. Cash flow improves, unit economics strain. The processor doesn't mind. Their queue grows, their bargaining power thickens, and their customers sleep better. The miners' share price pops on tonnage, not capture of midstream value. Here's the clincher. Even when non-Chinese separation scales, Malaysia, Estonia, a pilot in Texas, the road often still loops back for metals and magnets. A single missing step keeps the cycle dependent. A magnet factory's furnace profile is tuned to a supplier's alloy. Change the alloy and you change the furnace, the dyes, the diffusion recipe, and the failure modes. That's months of requalification while orders pile. Operations managers don't roll that dice unless forced. So mining announcements keep multiplying, and refining capacity still decides the future. The map looks diversified at the pit and concentrated at the pump house, until mines, separators, metal makers, and magnet lines live inside the same non-Chinese clusters, sharing people, parts, and panic rooms. The concentrates we celebrate will keep sailing back to the same gates. The new scramble, alternatives, hype, and hard limits. While all kept circling back to the same gates, governments and companies started sketching exits. In Washington, Canberra, Ottawa, rebuild plans landed with fanfare. The promise was simple: rebuild the midstream, stitch it to magnet lines, and turn vulnerability into industry. The reality showed up in commissioning logs: partial capacity, narrow throughput, long debugging tails. Start with the rebuilds you can visit. In the US, Mountain Pass advanced beyond carbonate, pushing into separated oxides with a roadmap to metal. Texas announced pilot separations and magnet fabs tied to defense contracts. Australia's leaners added lines in Malaysia and broke ground at home. Canada floated refineries in Saskatchewan and Ontario, chasing ion exchange flowsheets tailored to their feeds. These weren't press releases, they were concrete and steel. But they shared a constraint. Each plant could handle only certain chemistries at volumes that left global demand barely dented. Live production punished optimism. Yields wandered their first year. Customers tested lots, accepted some, rejected others, and hedged by keeping their Chinese allocations warm. Alliances arrived to underwrite patience. The EU published critical raw materials acts and deployment targets. Japan co-financed non-Chinese flows and magnet plants, building on the decade-old lesson of 201. Korea leaned into materials strategy, backing powder metallurgy and motor integration to buy down risk. These moves mattered because they moved risk. A magnet line with firm defense offtake can bleed through the messy middle without dying. A separator with a European anchor customer can fix crud problems without its lenders pulling the plug. But alliances don't print operators. They buy time for people to become them. Meanwhile, new frontiers flashed on maps. Greenland's rare earth-bearing deposits promised scale. Politics and environmental scrutiny promised delays. In Africa, projects in Tanzania, Burundi, Malawi, and Madagascar advanced, each with unique metallurgies community expectations, and power constraints. Belt and road tie-ins surfaced in port loans and processing MOUs, reminding everyone that geology without financing is a postcard. Some ore bodies looked clean, others carried penalty elements that turned separation into a chemistry marathon. A project could be world-class on grade and still stumble on water, reagents, or a bridge that trucks can't cross in rainy season. Deep-sea mining entered the conversation like a dare. Nodules on abyssal plains, rich in nickel, manganese, cobalt, and yes, trace rare earths, looked like a way to skip land politics. The geology sat a mile down, wrapped in ecological unknowns. Pilot collectors sucked nodules, environmental monitors recorded plumes and biota stress. Island nations asked about social license. Tech firms called the metal mix tempting, insurers called the liability undefined. Even if regulations greenlit trials tomorrow, magnet-grade flows would take years to standardize. The ocean wasn't a shortcut, it was a different map with slower clocks. Hype surged alongside hard limits. Startups pitched rare earth-free motors, switched reluctance, axial flux, high-temperature superconducting. Some worked for narrow lanes, forklifts, low-cost EV trims, wind turbines with larger nacelles. But torque density is a bully. In compact, high-performance applications, NdFeB still wins on watts per kilogram and heat resilience. Each magnet-free announcement carried footnotes: cost, acoustic signature, control complexity, scarce cooling headroom. Substitution shifts demand, it doesn't erase it. Recycling looked like a bright lever because it rode existing metal. Japan's consortia pulled magnets from hard drives, Europe funded urban mines, US labs demonstrated magnet-to-magnet loops, hydrogen decrepitation, selective leaching, powder resintering. The catch: collection rates, logistics, contamination, and product design. Heterogeneous scrap with mixed chemistries complicates re-entry to tight specs. The wins are steady, compounding. They just aren't sprinting. You can't recycle the first generation of a build-out you haven't completed yet. Then the quiet math surfaced. Bankability rests on offtakes, minimum volumes, and performance guarantees. New separators need long, patient contracts at prices that reflect true waste handling and learning curve loss. Magnet plants need customers who will tolerate early variance while tooling settles. Governments can anchor with defense and grid procurements. Commercial buyers can layer reliability premiums, a cent here, a nickel there, that make boredom profitable. Without those, spreadsheets default to incumbents. With them, the new map thickens. Microstory: a European wind OEM signed a 5-year offtake with a non-Chinese magnet maker at a premium tied to uptime guarantees. Year 1 hurt, rework, retuning, a recall on a small batch. Year 2 held. Year 3, a heat wave stressed everyone. Their line kept shipping on spec. The premium looked cheap compared to crane time on offshore towers. Unknown to viewers of ribbon cuttings, the hardest limit is people. A solvent extraction hall needs operators who have seen a phase inversion and don't blink. A metal shop needs technicians who can smell a vacuum leak before gauges twitch. A magnet press needs hands that feel when powder flows wrong. Training programs are starting, apprenticeships in Texas, Malaysia, Western Australia, exchange cohorts with Japanese and European veterans, but craft travels at human speed. China isn't standing still while others sprint. As rebuilds begin, Beijing nudges up the stack, integrating magnets into motors, motors into drive units, and drive units into cars, turbines, appliances. Export controls shift from material to know-how and equipment, narrowing leakage routes. Domestic recycling scales a step ahead, soaking internal scrap and thin film sources. The chokepoint doesn't disappear, it evolves. So the scramble splits into two truths. There are exits, and they work slowly locally at costs that reflect the bill we avoided. And there are limits that speeches can't erase. Chemistry has a tempo, permits have a tempo, trust has a tempo. The only way out is through those tempos, paid for up front, measured in boredom later. Strategic consequences, the military edge. Start with the grams that steer billions. In a guidance unit the size of a soda can, a ring of NdFeB magnets holds torque through heat and stress. Add a whisper of dysprosium or terbium at the grain boundaries, and the magnet stops demagnetizing at 180 degrees C. Take that whisper away, and your actuator droops under load. It's not drama, It's physics writing a flight path. Stakes are human before they're geopolitical. A maintenance chief in Utah opens a tote of fin actuators for a missile test. The serials match, the paperwork's clean, but a lot from an alternate supplier drifts on the dynamometer after thermal cycling. She signs a red tag, hold for engineering review. A test slips a week. Schedules ripple downrange. Readiness isn't a speech. It's whether a rack slot stays empty long enough to matter. Meanwhile, something else is happening on the carrier deck. A radar tech needs servo drives that don't drift when cabinets heat during sustained operations. Those drives use micromotors packed with high-grade magnets because there's no room for bulk. As the supply queue lengthens, a substitution plan lands on his bench. Lower-grade magnets with thicker laminations, new control firmware, retest in hot hold. He can make it work. He can't make time expand. Small parts, big outcomes is not a metaphor. A jet engine's variable stator vanes rely on actuators that must hold position at temperatures where aluminium softens. A ship's electric drive wants dense torque without a weight penalty that steals range. A drone swarm needs grams saved to buy sensors and endurance.